All right, buckle up, everybody, because today we're taking a deep dive into a scenario that's both thrilling and, well, a little bit terrifying.
Oh, and what's that?
We're talking about comets. Like, what if a truly massive one, bigger than the one that took out the dinosaurs, decided to pay Earth a visit?
I see.
You've provided us with some really fascinating material about this, so let's dive in and see what we can learn. First things first, for anyone listening who might not be a total space nerd like me, can you give us a Comet 101? What exactly are these things?
Sure. Well, comets are kind of like cosmic time capsules, remnants from the very beginning of our solar system, billions of years ago.
Okay.
Essentially, they're made up of rock, dust, and frozen gases all packed together.
So like a gigantic, dirty snowball from the dawn of time.
Yeah, that's a pretty good way to put it. And as this snowball gets closer to the sun, the ice starts to vaporize,
I see.
creating this hazy cloud around the comet. It's called a coma.
Oh, okay.
And it's this coma that gives comets their spectacular, almost ghostly appearance.
Okay, so beautiful, but potentially deadly. What makes comets so dangerous compared to, say, an asteroid?
It really comes down to a combination of size and speed. Comets can be absolutely enormous. I mean, some even dwarfing the one that caused the extinction of the dinosaurs.
Wow.
And they travel at incredible speeds. So when you combine that mass and velocity, the potential energy upon impact is almost unimaginable. Even a relatively small comet could release energy equivalent to multiple nuclear bombs.
That's definitely putting things into perspective. Speaking of massive comets, didn't scientists recently discover one that was absolutely colossal?
You're probably thinking of Comet Bernard-Nelly-Bernstein.
Maybe.
It's a behemoth, estimated to be somewhere between 62 and 230 miles wide.
Seriously.
Its orbital period is incredibly long, taking millions of years to complete a single loop around the sun.
Wow, okay. I'm officially feeling a little bit nervous now. So let's say, just for the sake of this deep dive, that we discover a massive comet like that heading directly towards Earth. What happens next? What does that scenario look like?
Well, if we're talking about a truly massive comet on a direct collision course, the first stage would be, well, detection and confirmation by astronomers.
Right.
Given the size, it's likely we'd have a decent amount of warning, maybe even years rather than just months.
Years, huh? That's at least a little comforting. But I imagine even with years of lead time, the news would cause complete global panic.
Absolutely. You'd have governments scrambling to figure out a plan, scientists racing against time to devise potential solutions, and probably a fair amount of societal chaos. You know, as people tried to grapple with the idea of an impending world-altering event.
And this thing would be visible in the sky, right?
Yeah.
Everyone would be able to see it getting closer and closer.
It would be impossible to miss. As it approaches Earth, a comet that size would become brighter and brighter in the sky. You know, a constant and growing reminder of the impending threat. It'd be a spectacle, no doubt, but a terrifying one.
So let's talk about options. Could we do something to stop it? I'm picturing a scenario like that movie Armageddon, where they send a team up to nuke the asteroid. Would that work with a comet?
It's not quite that simple, unfortunately. Remember the DART mission where NASA successfully altered the trajectory of a small asteroid?
Yeah.
That was a huge achievement. But asteroids are mostly solid rock. Comets are much more unpredictable because of all that ice.
Ah, right. So the ice makes them less stable and harder to predict.
Exactly. Their icy composition makes them behave in ways we don't fully understand. A nuclear detonation, while potentially effective on an asteroid, might have a completely different and unintended effect on a comet. It could fragment the comet, creating multiple smaller but still dangerous pieces.
Yeah.
Or it could even make the trajectory worse.
Okay, so nuking it is probably off the table. What other options are there? What about this gravity tractor concept I've heard mentioned? Is that a real possibility or just something out of science fiction?
It sounds like science fiction, but it is a concept being seriously considered. The idea is to position a very massive spacecraft near the comet. And over time, the spacecraft's own gravity would ever so slightly tug on the comet, pulling it off its course just enough to avoid a collision with Earth.
That sounds like it would take a very long time, though. We'd need a lot of advance warning for something like that to work.
You're absolutely right. Gravity tractors work incredibly slowly. That's why early detection is so vital when it comes to comets. The more time we have, the more options we have to potentially deflect or mitigate the threat.
All right, so let's say, despite our best efforts, the worst-case scenario happens. This giant comet can't be stopped and it slams into Earth. What does that look like? Paint me a picture, but go easy on the terrifying details, okay?
Well, let's start with the impact itself. The energy released would be equivalent to thousands of the most powerful nuclear weapons ever detonated, all going off at the same time.
Thousands. Oh, wow. I'm suddenly feeling very, very small.
To put it into perspective, the kinetic energy of a comet that size traveling at tens of thousands of miles per hour is astronomical. The immediate impact zone would be utterly devastated, with cities vaporized instantly.
And the impact would have global repercussions.
Yeah.
We'd be talking earthquakes, tsunamis, the whole works.
Absolutely. The shockwaves from the impact would trigger massive earthquakes and volcanic eruptions across the globe. Coastal regions would be inundated by colossal tsunamis, traveling far inland and wiping out entire cities.
And then there's the dust cloud I keep hearing about.
Yeah.
That sounds like a whole other level of catastrophe on top of everything else.
The impact would eject billions of tons of dust and debris high into the atmosphere. This dust cloud would spread around the globe, effectively blocking out the sun, plunging the planet into a state of perpetual twilight or even darkness for months, maybe even years.
That sounds a lot like what scientists call an impact winter. I know it's a popular topic in doomsday scenarios, but I have to admit, I don't fully grasp the implications. What exactly happens during an impact winter, and how would it affect life on Earth?
Well, that's a great question, and one that deserves a deeper dive of its own. It's pretty complex and, frankly, pretty scary. But the simplest explanation is that the dust cloud blocking the sun would lead to a drastic drop in global temperatures.
So no more sunny days. That's a bummer. But what would that mean for all life on Earth?
Plants rely on sunlight for photosynthesis, so a prolonged period of darkness would cause widespread crop failures and the collapse of entire ecosystems. Without food sources, animal populations would plummet, and the global food chain would be in utter chaos.
Wow, that sounds pretty dire. So in this post-impact world, would there be any chance of survival for humans, or are we talking complete extinction?
Well, that's a complex question, and honestly one that's very difficult to answer definitively. But let's delve into that a bit further after a quick.
Okay, so we're back, and I have to say, that last segment was a bit of a reality check. The idea of a giant comet hitting Earth and triggering an impact winter is definitely not the most cheerful thought. It makes you wonder, if things got that bad, would there be any hope for humanity at all?
It's understandable to feel that way. We're talking about a potentially catastrophic event unlike anything humanity has ever faced. But it's important to remember that humans are incredibly resilient. We've survived ice ages, plagues, and all sorts of other challenges throughout our history.
That's true. We do have a knack for adapting and finding a way, even in the face of seemingly impossible odds. But how would we even begin to survive something as devastating as an impact winter? Sounds like a scenario straight out of a post-apocalyptic movie.
Well, for starters, the effects of an impact winter wouldn't be evenly distributed across the globe. Some regions would be hit harder than others, so survival might depend on factors like geographic location, access to resources, and, of course, a good dose of luck.
So you're saying there might be pockets of survivability, places where the impact wouldn't be quite as severe.
Yeah.
It's a slightly more optimistic thought.
Exactly. And even in the most severely impacted areas, there's always a chance that some individuals or small groups might find ways to adapt and survive. Human ingenuity is a powerful force.
True. Okay, let's shift gears a bit and talk about the other side of this coin. We focused a lot on the potential doom and gloom, but what about the potential for preventing a comet impact in the first place? You mentioned earlier that early detection is key. What kind of technology are we talking about?
Astronomers are constantly scanning the skies for near-Earth objects, including comets.
Yeah.
They use powerful telescopes and sophisticated software to track their orbits and assess any potential threat to Earth.
So we're not just sitting ducks waiting for a comet to sneak up on us, we're actively looking out for them.
Absolutely. There are several dedicated programs around the world focused on identifying and tracking potentially hazardous objects in space. The sooner we spot a potential threat, the more time we have to react.
That's reassuring. So let's say we do detect a large comet on a collision course with Earth, and we have, let's be optimistic, several years' notice. What can we actually do to prevent an impact? Are there any viable options on the table right now?
There are a few ideas being explored, and some are more feasible than others. One concept that's often discussed is using a kinetic impactor similar to the DART mission, but on a much larger scale.
So basically ramming a spacecraft into the comet to nudge it off course.
Exactly, but we're not talking about a small probe like DART. To deflect a truly massive comet, we'd need a much larger and heavier spacecraft, perhaps even an array of spacecraft, to deliver enough kinetic energy to make a difference.
And I imagine getting that kind of spacecraft built and launched in time would be a monumental task.
It would be an incredible engineering feat, requiring global collaboration and a massive investment of resources. But in the face of an existential threat, it's the kind of challenge humanity is capable of rising to.
What about other options? You mentioned nuclear detonations earlier. Is that something that's still being considered as a last resort?
The use of nuclear weapons to deflect a comet is highly controversial.
Yeah, I can see why.
While it might be effective in theory, there are significant risks involved. Detonating a nuclear device near a comet could create a lot of radioactive debris, which could pose a threat to Earth even if the deflection is successful.
That makes sense. It's not a solution to be taken lightly.
Yeah.
And honestly, it sounds a bit like trading one disaster for another.
Exactly. It's a very risky proposition, and it would only be considered as an absolute last resort if all other options had been exhausted.
What about the gravity tractor idea we talked about earlier? Would that be a more viable option for deflecting a large comet?
The gravity tractor concept is appealing because it's a non-destructive method.
Right.
It relies on the gentle tug of gravity rather than brute force. But as we discussed earlier, it requires a lot of time to work.
Years, if not decades, right.
Exactly. So for it to be effective, we'd need to detect the threat very early on, ideally decades before the projected impact.
So it seems like there are options on the table, but each one comes with its own set of challenges and risks. What about preparing for the aftermath of an impact, even if we can't prevent it? Are there any steps we could take to mitigate the damage and increase our chances of survival?
That's an important question. Even if deflection efforts fail, there are things we can do to prepare for the potential consequences. For example, we could establish underground shelters stocked with food and supplies.
I see.
Develop technologies for purifying water and air, and create seed banks to preserve the genetic diversity of our crops.
So basically creating a kind of modern-day Noah's Ark to safeguard humanity and the essentials for rebuilding.
Exactly. It would be a monumental task, but it's something we need to start thinking about seriously. It's better to be prepared than to be caught completely off guard.
All right, well, this deep dive has definitely given me a lot to think about. On one hand, the idea of a giant comet hitting Earth is pretty terrifying. But on the other hand, it's inspiring to see how humanity is tackling this challenge head-on, with innovative solutions and a determination to survive. What strikes me most is how this scenario really highlights the interconnectedness of everything on our planet.
It really puts things in perspective, doesn't it? It reminds us that we're all in this together, sharing this fragile planet in the vastness of space.
Exactly, and that facing a threat like this would require global cooperation and collaboration on a scale we've never seen before.
Absolutely. It would require a shift in thinking, a recognition that national borders and self-interest become meaningless in the face of an existential threat to all of humanity.
Well said. This has been a fascinating and thought-provoking conversation, but I think it's time for us to take a short. We're back, and this whole conversation about comets has really got me thinking about our place in the universe.
In what way?
Well, on one hand, it feels incredibly humbling. You know, it's just this tiny little planet hurtling through space, surrounded by all these potentially cataclysmic forces that we have very little control over.
It definitely makes you realize how fragile life on Earth really is. We often take it for granted, but it only takes one cosmic event to potentially change everything.
Exactly. But on the other hand, I'm also feeling a sense of awe and inspiration.
Really?
Yeah. Despite the very real dangers out there, humanity isn't just passively accepting its fate. We're actively seeking out knowledge, developing technologies, pushing the boundaries of what we can achieve.
It's a testament to our innate curiosity and our drive to explore and understand the world, or in this case, the universe around us. It's what sets us apart as a species.
Thinking back to the DART mission, that was a pretty amazing feat of engineering and a huge step forward in planetary defense. Makes you wonder what other incredible technologies we might develop in the future to protect ourselves from cosmic threats.
The possibilities are truly exciting. We're already seeing rapid advancements in fields like space exploration, robotics, and artificial intelligence. Who knows what we might be capable of in the next decade, or even the next century?
You know, as we've been discussing this, one thing that keeps coming to mind is how a scenario like this, a giant comet on a collision course with Earth, would really put our priorities into perspective.
How so?
Well, it would force us to confront some fundamental questions about what truly matters.
It's a stark reminder of the things we often take for granted. The things that truly make life worth living. Our relationships, our connections to nature, the pursuit of knowledge and understanding. These are the things that would likely become even more precious in the face of such a crisis.
It's a thought-provoking idea, isn't it? That facing an existential threat might actually help us rediscover what's truly important and bring us together as a species.
It's a powerful concept. And perhaps, even in the absence of an immediate threat, it's a reminder to cherish what we have, appreciate the beauty and wonder of our planet, and to work together to ensure its survival for future generations.
Well said. This deep dive into comets has been a wild ride, full of terrifying possibilities, but also inspiring insights into human ingenuity and our capacity for resilience. It's left me with a sense of wonder and a renewed appreciation for the fragility and preciousness of life on Earth.
It's been a fascinating journey, exploring the science, the risks, and the potential solutions. And ultimately, I think it underscores the importance of knowledge, of continuing to explore and understand the universe around us so we can be better prepared for whatever the future might hold.
And on that note, I think it's time for us to wrap up this deep dive. A huge thank you to you for sharing your expertise and guiding us through this complex and captivating topic. And to our listeners, thanks for joining us on this journey. We hope this deep dive has sparked your curiosity and left you with some food for thought about our place in the cosmos.